So I'm Megan Shamas. I am the lead developer for the FIDO Alliance. Just kidding, I'm not at all. I am the director of marketing for the FIDO Alliance, so I lead all of our external comms and market adoption programs. Let me introduce you to our speakers today. So you have myself, you have Shane Weeden, who's a senior technical staff member at IBM, Matt Miller, engineering tech lead at Cisco, and Nick Steele, who is a staff product manager at 1Password. And these three are heavily have contributed to not only FIDO Alliance, but to W3C and WebAuthn, and they are the right people to be talking to you today about how to enable passkeys for your sign-ins. So what are we going to talk about today? Okay, so first we're going to just go through a little bit of like, okay, why are we doing this? Like, why is this timely? What exactly is a passkey? If you already have MFA, here's what you should be doing. Evolve into Passwordless. We're going to do a demo, go through some developer gotchas and myths, key takeaways, and then we should have some time for Q&A as well. So why are we here? So it's been 1 year only, which seems crazy. It's only been 1 year since we announced the availability of synced passkeys, which enable FIDO credentials to be securely synced across devices and platforms. And since then, it's been, really, so this is a definition of passkey. However, I'm going to skip this one because Shane is going to tear it apart in about 4 minutes, tell you a little bit more in depth about what passkeys are. But since then, incredible amount of momentum and support. So embraced by platforms, that means support built into every leading operating system, and also credential providers. So folks like 1Password, Dashlane, Bitwarden, so your password managers are also working to become passkey providers as well. So to give folks some choice of where they're keeping their passkeys. So everyone's sort of working together to enable this ecosystem of support. And it's been actually truly, truly awesome to see all these folks enabling so quickly. Like I said, only 1 year. And we're also seeing more and more online services start to roll out sign-ins with passkeys. Most very notably, Google announced a couple weeks ago full support for Google account. That's huge. Christian, congratulations and thank you. But every day we hear of more and more folks that are really eager to start rolling this out, mostly on the consumer side. But these are some examples of some folks that have already enabled sign-ins with passkeys. And with that, let me have Shane Weeden come up and actually talk to you a little bit about how we should be thinking about passkeys.
Thanks, Megan, and thanks, everyone. It's great to see such a big crowd here. If you don't know me, I'm Shane from IBM. I've come all the way from Australia to answer this question for you. But more importantly, I don't just want to leave you with the information about what a passkey is. I want to enable you to have the what is a passkey discussion with people from all levels of technical knowledge, whether it be friends and family that you guys are probably the IT support crew for, as I am for mine, or whether it be colleagues that you work with, right? So think about this discussion as I'm going to be able to retell this story about what a passkey is to other folks in the industry and my peers. So if you're new to FIDO, this is my one slide, what FIDO is in a nutshell, right? This is an easy way to have a discussion about what problem it is we're trying to solve and how we differentiate FIDO authentication from the problems associated with passwords. And pretty much every problem associated with passwords stems back to one key ingredient, which is just human nature. It's as simple as that. This is the way people behave, and as a result, we've created this problem for ourselves. If you've never heard or understand how the protocol actually works, right? And this is something I can also explain to folks of all different levels of technical knowledge, is just explain the difference between a symmetric secret and an asymmetric secret, right? So this is the way I describe it, as a challenge response mechanism. There is a piece of information securely guarded on the client. There is a piece of information stored on the server associated with my user account, which is a public key. And when it's time to log in, this is what happens. The client says I'm ready to log in, and the server provides a random challenge. The challenge is just a big, long, random number that is used to prevent replay attacks. Now, you're not going to have that conversation with your mum, right? But you can have that conversation with technical people that need to understand how the protocol works. The client then signs the challenge with their private key, and the server says, "Goodo, here's a session cookie. We're done." That's the simplest way to describe the protocol. The same protocol is used for registration. I didn't show registration. The difference being there's a pre-established session, and the ceremony is used to establish the private key with the public key with the user's account. And that's why it's called a trust on first use protocol. So you have to have an authenticated session to establish a public key with your account, and thereafter this is the authentication ceremony. So back to Megan's definition. I call it Megan's definition. It's a marketing definition. This is the type of definition of a passkey that we use when we're talking to stakeholders that aren't the geeks writing the code for our websites, right? The whole point of this protocol is to replace passwords on the internet with something better. So this is a bit more of the technical definition of what a passkey is. For those folks who understand a little bit about FIDO credentials, a passkey is any discoverable or formerly known as resident key credential. This means that the private key, along with metadata associated with the account, such as the user's display name, is stored and can be exercised from the authenticator at the client. This is important because it allows us to do client-side credential discovery without first having to go to the server and say, "Here's the username, give me a list of credentials back." So the important differentiator here is that discoverable credentials can be used in, as Christian likes to say, typingless login flows. We don't even need a username to begin a passkey authentication. Okay, so that's the technical definition. Why passkeys are exciting, and one of the reasons I actually got involved with FIDO is it's one of the very few times in the history of the internet that you get an improved user experience and an improved security posture at the same time. That's a very good, easy technical point that you can use to sell the passkey story to stakeholders in your businesses. Now, most people in our industry, when they think and talk about passkeys, they talk about the subset of passkeys, which are synchronized across platforms. So, truly, FIDO's definition includes device-bound security keys, such as those from Ubico, Talos, FIDO, and a whole bunch of other providers. But more commonly, people think of passkeys as those that are synced across a fabric to multiple endpoints. And the reason why that's important is that it helps with the account recovery problem should you need to get access to your private key back if you lose your phone. And really, to be fair, in the wild today, the only predominant one is the one from Apple. Apple Passkeys were released last year and starting to gain traction. But you will see more vendors, not just those from the big platform providers, but also, as Megan suggested, password providers from traditional password manager vendors come onto the market as well. So this is, as I was saying, what most people think of when they think of a passkey. It is one that is synced across my devices, such as my iPhone and my Mac. But please expand your horizons on that and think of a passkey provider as inclusive of those other either consumer-facing or enterprise-style password manager vendors as well. Now, it's not entirely roses when it comes to talking to security people about using synchronized passkeys, particularly, I would say, in the enterprise. Because one of the things that you do when you have one of these passkeys that can synchronize themselves across a cloud fabric, as opposed to one that's bound onto a hardware security key, is that you are necessarily ceding some control over the security of that to the provider of that passkey. So keep that in mind as well. We'll talk some more about that in a minute. So this is the question we see all the time. Do I still need 2FA if I'm using a synchronized passkey? I would say in 95% of particularly consumer-facing use cases, you probably don't. The real thing you need to do is zoom out a little bit and have a look at your threat model and ask yourself this question: why did I introduce two-factor in the first place? And if the answer to that question was to reduce the threats associated with credential stuffing and phishing attacks, then the answer to this question is no. If there are other reasons you introduce 2FA, the answer might be maybe. Right? So, just a little bit about this spectrum here. Passwords, this is the low end, this is shitty, this is good, okay? This is good, this is shitty down here. Okay, so the gold standard for FIDO credentials is your hardware device-bound passkey. We introduced conditional second factor authentication to mitigate some of the threats associated with credential stuffing in particular, and password reuse and password leakage. Not phishing, by the way. Most 2FA is totally still phishable. And that's one of the reasons why we have syncable passkeys up here, much higher to the right, because it also addresses the problem of credential phishing. You can't present a device, a relying party bound passkey to the wrong site. The browser simply won't let you, unless your CA cert list gets compromised, and that means your browser's compromised, and then you were screwed a long time ago. Okay, so that's why we keep it to the right. I think there is a place in here. I don't put a dot here, but I think there is a place in here for some subset of use cases where people might want to use a synchronized passkey plus conditional multi-factor, particularly in the enterprise space where you might want to control the lifecycle management of that second factor yourself, right? That is a fair thing to say at the moment. And it's just something you have to think about for yourselves. What's your particular deployment threat model, and how does that fit in? Okay, so I'm going to switch to a live demo today because I get a lot of criticism from my colleagues about doing recorded demos, mostly Christian. So let me do that and show you a authentication with a passkey. And I'm going to use one of those sites, not because I have any affiliation with Kayak, but I'm going to use Kayak because I think their passkey login is really cool. So I already have a credential registered at Kayak, and in fact, I'm using kayak.com.au, the Australian version of this site. This is the login experience for me. I click sign in. Yes, I'll continue with email. And before I even have the opportunity to enter my email address, the autofill feature that's available in WebAuthn shows me my passkey, just like it would if you were doing autofill for a password. I select it, perform Touch ID on the Mac, and I'm logged into the site. It's the exact same experience as I have when I use any native mobile phone app, right? And that's the type of experience that we want to bring to websites across the entire internet. No password on that site for me. Now, having told you now what a passkey is and how to use one, just like I did there, I'm going to hand it over to Matt Miller, who's going to tell you how to take your site on the journey from where you are now to where you want to be, and give you some bit more of a developer insight into exactly how to do that.
Great, thanks, Shane. So I want to talk about now the spectrum of for websites where you currently have second factor incorporated, or if you are a website that doesn't have second factor incorporated because for a variety of reasons, like it's a tough thing to manage. What I want to talk about here is, first off, if you're already doing MFA, what do passkeys have to offer you? So the first easy thing is if you're already using WebAuthn as a second factor, you're this close to adopting passkeys, because WebAuthn itself offers websites the ability to do multi-factor authentication. So if you're using WebAuthn as a second factor, you're only getting one factor out of that, but it's very easy to tweak your usage of it such that both of those factors, in lieu of password plus WebAuthn, all of it can be handled with passkeys, just as Shane showed. Without express disablement. Oh, wow. The point here, if you're not using WebAuthn for a second factor, you're using like a traditional SMS OTP, you can gradually roll in passkey support in a way that supports both like concurrent use of passwords plus second factor, and as you gradually migrate your users over. And in fact, later this week, the FIDO Alliance's UX working group is going to have a lot of great information on there on how to kind of guide your users through that. Now, if you're not doing MFA at all, now is the time to consider adopting Passkeys instead. Because as Shane mentioned, for 95%, give or take, depending on who you ask, of consumer-facing use cases, like Passkeys, oh, that's right. I can't use this one because it's not on, can I? So if you don't have second factor incorporated at all, if you are a consumer-facing website, for probably 95% of you, Passkeys can be used now. The ecosystem is mature enough. The platform providers are ubiquitous enough. The operating system support is there across all the major mobile operating systems, as well as desktop. Support is evolving as well and getting close to support across the board. If you are considering SMS OTP as your second factor, there's a very real cost associated with incorporating telephony into your product. You're paying to send out SMS messages, and if at a certain scale, that becomes a very real operating expense for your organization. So you can just completely remove that line item from your expenses if you go with something that's based on Passkeys, because there's no cost to use it. Also, you can benefit from the fact that users, like mobile phone users especially, which is all of us, we're all used to using Face ID, and we're all used to using the fingerprint sensors on our phones. And that familiarity with biometrics means that there is less effort for you to educate your users on how to enroll something in biometrics, how to use biometrics, because your users are already using it for Apple Pay and Google Pay, sorry. I don't know what the current name is. And just even unlocking your phone. And now, because mobile phones can play such a prominent role in the adoption of Passkeys and using Passkeys to sign in, everyone has a mobile phone, so they've got something that can do FIDO. Let me use this clicker here. There we go. So I don't need the mic because it's demo time. So what I want to show now is rolling out Passkey support is not something that you're going to do overnight, of course. For any websites with a sizable enough user base, whether that's internal users or like a B2C kind of setup, you're going to want to gradually roll out Passkey support. And so what I'm going to do is I'm going to tempt the demo gods a little bit here, and I want to show you what that journey can look like. So first of all, I have here a modified version of WebAuthn.io, which is a site I maintain as well through, it's part of Dual Security. This is kind of your typical username, password plus SMS OTP login. So you're gonna provide your username, and you're gonna say, type in a password. Oh, that's right. I need multi-factor. Hold on. Gotta unlock. Hold on. Is that? Oh, that's right. That was in Duo. Hold on. All right. I'm gonna grab my. Okay. All right, hold on, I gotta. Shh, you didn't focus that. Hold on a sec. There we go. All right. Okay, now I'm logged in. So, okay, it's fine, I guess. A little time consuming, and usually once you do it, you're probably not going to be doing it too often. But it can get better. You can offer a better user experience for your users. So what I'm going to do here is I have some code open. And I am going to, where is it? Now, what we're going to do is, you've decided that incorporating Passkeys for multi-factor, you want to evolve your site to support Passkeys. So the first thing you're going to do, wrong way, is you're going to add a sign in with Passkey button. And this will be an optional way of signing in for your users that have gone through username and password and SMS OTP and ended up on the dashboard, and then click that register a passkey to add a passkey to their provider, whether that's the local platform authenticator or mobile device. So now they've got a passkey enrolled in your system. So now what they can do is they can sign in with a passkey. Oh, you know what I didn't do? Okay, hold on. I forgot to add one. And also this is fake, so just skip past that. So I'm going to go ahead and register a passkey. So here is my passkey for my account on WebAuthn.io. So now I'm going to log out. Now, I reload the page one day and I see this sign in with a passkey. I'm like, hey, that sounds really cool. Let's try that. So the browser prompts me to use it. I use Touch ID, and I'm in. Instant time savings. Now, so just look at this again. Nothing has really changed, and you're not going to spook too many of your users because nothing has really changed about the authentication screen. They have the username and the password field that they're used to. You've probably sent out communications internally going, hey, be prepared for the site. It's going to change in 3 weeks, and no one's going to read it. And in 3 weeks later, they're going to see this sign in with a passkey button, and maybe they'll have heard through the grapevine, hey, this sounds like something I want to try, and they'll try it, and they'll see that it's a better experience. So then you'll start having more and more people ask you about signing up with a passkey. And once you reach some critical threshold where you're confident enough that the majority of people are ready for a more full-featured passkey flow on your site, then you can take things to the next level, and you can incorporate autofill support. Now, take a snapshot of this in your mind, because I'm going to refresh the page here, and it's going to look radically different. Where did that password field go? Well, once you've decided that passkeys are the way you want to handle your multi-factor authentication, you can completely remove passwords from your sign-in. And this is not a contrite example for the sake of this demo. This is a very real end state that passkeys enable you to achieve today. And so this goes back earlier to the typeless login experience. So let's say you come in here and you click on this username. Oh, what's this? It's the password autofill, except it's not suggesting a password. It's suggesting a credential, a passkey. So the user clicks it, they do Touch ID, and they're in. And so, it's just so, I love going through this myself because I'm just like, damn, I wish I had this everywhere. It's such a nicer experience versus even like no offense to password managers, they are fantastic for managing all of the various passwords that you're supposed to not, keep track of but not remember. But this just feels better to me as an end user, and so that's why I really hope you can kind of see the UX improvement that this can provide you. So if this live demo wowed you in any way, and I do have some code here. I need to clean it up maybe a little bit, and I can push it up online if you do want to take a look at it. WebAuthn.io, as far as a demo site, is maybe not full inspiration, but it can, I think, maybe help you a little bit consider the changes to your login process. So if that was compelling to you in any way and you decide, oh, hey, Passkeys is something that I want to embark on and start learning about, I'm going to hand things off to Nick because he's going to have some answers to very common questions that come up for those of you who maintain authentication flows and decide you want to head down this path.
All right. Thanks, Matt, for that killer demo. That was awesome. Hi, I'm Nick Steele. I'm a staff product manager at 1Password now. So Matt did some really brave live coding there, and there's a lot of development that we've all put into WebAuthn over the years, and we've had a lot of what I'd call gotchas that we've seen, and we get a lot of questions about. So I want to cover some of those gotchas we've had as a developer. This is by no means a extensive list. This is just a few things that we've been getting questions with recently, and then as we go into, after we cover that, we'll kind of go into some myths around passkeys as well that we often see on social media and elsewhere in organizations when we start talking about passkey deployment and really the fear of moving towards passwordless at scale. So some developer obstacles that we still have. I mean, the first one here is Matt showed a great demo of conditional UI towards the end there, or it's also known as conditional mediation, and that's when Matt hit that field, the autofill field, to enter his email, and we saw that credential appear. So that conditional UI will fire a request on first load. This is a bit wonky for some. So what I've found from working at 1Password and Passage is sometimes if we're doing authentication correlation, and other organizations can see this too, you may want to either discard or tag that event on your front end, and then use that as an ID, because sometimes there may be a case where you want to fire a second request because you don't want to catch that first one. Conditional UI is in development by platforms, so it works in Chrome, it'll work in Safari, will work in Firefox, but it's definitely they're still polishing it out, but it should be done quite soon. I mean, you could already use it. Passkey providers right now, like myself, have to inject themselves into the DOM. So if your organization is disabling JavaScript, serving your own, you may see this in larger, more high assurance organizations where you have your own potential CDN for deployment. This could cause some obstacles with us operating in that space. So if you have a rollout of 1Password, Dashlane, any other passkey provider, then you may need to allow us to operate in there. This may change in the future, but definitely something to keep in mind right now, especially as groups like 1Password start talking about passkeys in our product later this summer. So there's also limited ways to infer what device or the type of passkey you're going to get before you receive it. This is done for a few reasons. The biggest being user privacy. We don't want to give away any information, and this is written into the WebAuthn spec. We don't want to give away any information that may allow the user to get fingerprinted. So at the center of Passkeys 2 is user privacy. We're creating this strong scoped and unique credential that could be used on a website to help not only protect you, but protect the user that's using it as well. So because of this, we can tell you if the user will be able to create a passkey, but we may not be able to tell you quite up front where it's coming from. So when you're making UI and UX decisions for your product, consider that up front, because you may not know if the user is going to be providing a YubiKey or FATN token, a hardware token, or using 1Password or using Google. So the general guidance right now is to look at that passkey, or try to figure out what the passkey is after you receive it, rather than before. But as we keep developing this, there should be more ways to infer what kind of passkey you're going to get, at least without giving away anything about the user's identity or hardware. So going into myths a bit, I think Shane covered some of this up front. We also have some data coming back from 1Password and the Passage team now around some of the sentiment around this. So passkeys are not vendor specific. This is generally what we hear about a lot. They tend to get associated with Google and Apple probably the most. And this is a good bad thing. This is very much a product for or an open source standard. Passkeys are based on the FIDO 2 framework, which includes the WebAuthn standard, which is in W3C, and then CTAP2, which is in FIDO lines. And passkeys are not meant to replace WebAuthn. So the WebAuthn standard is essentially just a browser API. And it allows us, when we're talking about passkeys, to create two types of credentials. Non-discoverable and discoverable is what they're called. But passkeys are this discoverable type of credential. So they're a subset of what is possible to do with WebAuthn, and definitely not something that is new or different than these standards that have been in operating for a while now. Passkeys are not only for phones, and Matt showed in his demo using biometric. We don't necessarily need to use biometric, but users are really comfortable using biometrics already on their phones and other devices. But you could do this with a PIN. You could be using a hardware token, and you could have a PIN associated with that, which will give you some idea around the user's identity, or at least that they can verify with the device. But it doesn't need to be a phone. In fact, you can sometimes use these hardware keys with a phone. What the phone helps with is that adoption layer. Over 80% of folks in the U.S. have a mobile phone. There's some countries where this penetration is even deeper. So being able to have this device that is capable of syncing these keys and having an account associated with it really just makes adoption easier for everyone. These passkeys can also be device-bound. They don't necessarily need to be shared and syncable. In some high assurance environments, you may not want this to, you may not want a passkey to leave the device. And as Shane was talking about, sometimes you may want a additional MFA step on top of it with the passkey. So one of the other, I think modalities that we're thinking about with Passkeys is, how do we start talking about hybrid auth to apps on TVs, your refrigerator for some reason, or other devices that may not have the same sort of interfaces that phones and shared keys could have. The syncability layer kind of helps solve some of that issue. So we kind of covered this before. All passkeys are not synced. We can have this hardware token still. So if your organization does want that high assurance, passkeys, you don't have to be afraid that passkeys are going to lower the security bar. In fact, it raises the security bar for your whole organization. And you can apply company policy alongside your passkeys. If you control the endpoint, you control the passkey. And I think a lot of folks really get lost in the sauce of what I can do and what I can get out of passkey via attestation and additional extension information associated with these keys. Where really most of the time, if you control the endpoint and you have corporate policy already, you can get the same information or telemetry, or even better, that you're already that you're trying to get out of just having a passkey deployed. So it doesn't. There doesn't need to be a policy directly attached. You can enforce policy around the passkey through sort of out-of-band channels. So that's kind of I feel like the big question and the big response we've been getting a lot of is, how do I support passkeys if attestation is not possible? Well, attestation can provide some assurances about the authenticator itself, but a lot of the time, what folks are going to want is not information so much about the authenticator, but about the endpoint, the state of it, when the user's logging in, where they're coming from. And that sort of policy is something that you're not going to get out of attestation on top of a passkey. You're going to get authenticator information, which is something that you, as we mentioned above, you can probably already get. So don't feel like that there's additional steps and additional things that you need on top of this passkey that you don't already have. In most enterprise cases, you're already going to have these tools available. And our piece in even stricter states or stricter environments can already use out-of-band techniques to prevent passkey misuse. And if you are afraid of this misuse happening, then it's super easy to re-roll a passkey, and it's going to get easier as time goes on. So those are kind of the myths that have been floating around. I hope I've dispelled some of them for you. To add some additional numbers, Matt kind of showed this at the beginning, but logins generally, and you can Google all sorts of like how long does it take to log in. Generally, you see amounts from 19 seconds to 30 seconds. It takes a while. We found in our organization that passkey login takes less than 4 seconds on average. It can go quicker as well, but on top of just like taking your organization to a more secure posture, you can help lower costs. I've seen organizations spend 5 figures a month or more on just SMS fees alone. You can help provide a higher security bar through these strong, scoped, and unique credentials based on PKI. And you can help enroll users or get your users adopting this pretty fast because they're already used to some of these modalities that you already have, using biometrics, logging into apps with their phone. This is all pretty common stuff nowadays, and Passkeys makes it really easy for you not only to deploy this internally, but to help raise your security as well. So I mentioned that Passkeys are already being used at scale. Well, you can start using them today with Google. If you go to g.co/passkeys, you can add a passkey to your Google, your personal Google account today, and start using it for higher security. And coming soon, you'll be able to add that to your workforce through Google. So if you're a G Suite customer, this is a fantastic way to raise the bar without lifting a finger, really. If you're using Google for login right now, have users add passkey, and you can enforce that. So the other takeaways here, that we want are like we're still talking about phishing-resistant WebAuthn credentials at the end of the day. This is based on open, secure standards that have been developed by leading folks in the industry to help provide a really accessible way to authenticate. So it is superior to MFA, but as we mentioned before, and we do want to say, it's like there still may be cases where you want to have MFA in high assurance environments. But this is the means to moving towards passwordless for the vast majority of folks. With Google adding support for passkeys, this adds support to over 3 billion devices in the world. People have access to this technology, and it now comes down to all of you to go help implement it and help users improve their security, both at work and at home. So it's easy and drop-in ready if you want to do it yourself. You don't have to lean on Google. And if you're already using WebAuthn, then you really don't need to do a whole lot. And we have some resources that we wrote ourselves. So Tim over here helps maintain passkeys.dev, and Matt helps maintain webauthn.io. We also lead a community group in the W3C, which is the WebAuthn Adoption Community Group. We don't have the same IPR agreements as the working group, so if you're interested in asking us any questions or getting feedback on your deployments, we're here to help users adopt this. And this is part of the reason that all four of us are on stage today, is we're coming from very different parts of the industry. I'm coming from a passkey provider standpoint. Matt and Shane are coming from more of the consumer and RP side of the house. But we want to be a united front in saying, this is the technology that's really gonna change authentication for users in the next few years. So feel free to come ask us questions there, or even here at the conference. We'll be here all week. Please use us as resources, either online or offline. And if you're interested in sort of explaining anything that I said towards the end here, or what was covered in these demos, we'll have the code. Feel free to go to FIDOalliance.org/passkeys for kind of more of a CXO angle to a lot of this. I think that's about it.
Hello.
Thank you very much for letting
Thank
me
you.
close this out.
Thank you.
Oh.
So we do have some time for questions. I'm going to run the mic around. So if you have a question, we've got like 13 minutes, so raise your hand and I'll come find you. Any questions? Okay. I mean, I'm not actually going to run. I'm going to walk quickly.
The question is related to the private key, a part that is shared between the devices. Is it one private key that is actually distributed to the other devices, or each device is generating a private key that it is storing? That's the first part of the question. Second part is the signing part. So I think you showed how a random string is coming back to the client, and client is signing it with the private key, right? That part, is it happening in the browser, or is it happening on the hardware somewhere on a secure enclave or on the mobile device?
That's a great question, and one we get a lot too. So what the WebAuthn API supports is it's essentially just a way for the browser to create and use credentials that are being created and then managed by a TPM or a secure enclave, or even in 1Password's case, we're managing it within our own extension. So when we create these private keys, because each site is going to get its own key pair for login, because that's what's happening. A WebAuthn credential is going to be a public and private key, and the private key is never going to leave this authenticator, and it's going to be unique for that site. So the private key, and this is where passkeys I think really are changing things, especially with syncability, right? Where now the private key is moving, but it's always going to remain encrypted and secure, and it's going to move into a different part of, I'd say, the same, what we're calling the sync fabric. So once that private key is created, it stays in that authenticator's possession, and then when we need to do any signing, we'll use the WebAuthn API to get a request from the site, and that'll contain a challenge and some additional information about the client. And then we use that private key within our authenticator boundary to sign that request and then hand back the signature. And that is basically the verification response that the website or the RP, the relying party, needs to verify a user.
Just to address your question directly, it is the secret sauce of the passkey provider as to how the private key or the ability to exercise it travels between device to device. So whether it's Apple's Sync Fabric or Google's or 1Password's, they all have their own proprietary schemes for doing that. And if they're any good, they publish them for scrutiny. Apple's is, for sure. Yeah. And I think Christian, Google's is too, yeah? The sync fabric sort of technique, yeah.
Shane's direct, in case anybody hadn't met him before. I've got a few over here. So, okay, go one at a time.
Yeah, do you see NIST pushing Passkeys and WebAuthn more? I think about NIST AAL1 is really around OTP, right? OTP.
Well, AAL1 is sort of it's just identity known. So here's what I'll say. Both folks in the WebAuthn working group and the FIDO Alliance are contributing to NIST 863-4. So I expect updates there that will make it more passkey friendly. I expect that for synced passkeys will probably land at AL2. Yeah, I'm seeing some head nodding from folks that know more than me.
Currently, if you're following NIST guidelines for FIPS compliance, passkeys will get you to about AAL2 in most deployments.
Yeah, and then if you want to go beyond that, use a hardware-bound authenticator from one of the big security key vendors.
Yeah, that's what they're saying for AAL3 anyway.
Yeah, that's right.
It's just interesting how, in my opinion, Passkeys WebAuthn sort of redefines that, right? AAL1 should not even be a minimum requirement. That should be excluded. Like if you're at that level, you need to adopt something like Passkeys and go with AAL2. Right. That should be the new bar.
Hi. Great presentation, thank you. I have a more technical question. So when we move from the passwords to the passkeys or FIDO, basically, we are changing on the backend side. In the passwords, we basically calculating hash and comparing hashes. In the passkeys, we are doing the public key verification of the signature. So my question is are there any performance implications of this change? And obviously at scale.
It depends by key type a little bit, but in my experience with EC256, which is the most common one, it takes about that long. I haven't seen any performance. So we have a big deployment internally for employees in IBM. We've not seen a single problem with authentication performance related to the difference between checking a hash password and doing a public key signature verification. It's almost negligible.
Oh, thanks, Megan, for running the mic.
Thanks for the presentation. I want to expand a little bit on the first question when you say migrating or enhancing from WebAuthn to Passkey. So it pretty much seems like there's really not much need to be changed from the relating party side, as long as your client is still sending the same public key signs.
Finally. Question for me. Yeah, so in terms of, there's this kind of spectrum of WebAuthn use. You have second factor, then you have passwordless, and you have usernameless, aka passkeys now. And in terms of how you're actually invoking the API call, there's a couple of options that the passkeys.dev documents this really well that are recommended that you set to ensure that you're getting multiple factors of authentication in a single gesture. But if you've already got the libraries in place and the back-end validation and everything going in, all of that should handle the slightly modified responses just fine. And from an end user perspective, there's almost zero impact, if any, that you'll have to educate them on.
Yeah, if you really want to know, the major difference is you set resident key to required, which requires you to get a discoverable credential versus potentially a undiscoverable credential. And there's a notion of user verification, which you should set to either required or preferred. And I think for the most part, the current recommendation is preferred. And then you utilize your risk engine to decide whether you want to do anything else beyond that if you get back a credential that's not presented with user verification. So that's the nuts and bolts of the difference between vanilla WebAuthn and WebAuthn with the Passkeys profile.
And an important thing to call it too here is Shane said that these options are preferred. It doesn't mean that you'll get this in the response unless you set things for required. So that's why our guidance is to sort of infer what you've gotten from the authenticator after authentication. Don't try to basically pigeonhole a user's authenticator before they go through the authentication event. Because once you get a response back, you'll be able to say like, oh yeah, this is a hardware or a single device hardware bound credential, and we can use that to do XYZ and show the user a different flow post authentication rather than pre.
I think maybe one more, Megan. We just got the red sign back there.
Okay, cool.
The passkeys are tied to the user account and website, if I'm not mistaken. So
Yeah,
the
that's
website,
correct.
can it be a top-level domain? For example, in the example you just demonstrated, if it's kayak.com, it could be flights.kayak.com, hotels.kayak.com. So if I want to use a passkey at a top-level domain to get signed into any of these subdomains, so is that a...
That's correct, yeah.
Okay.
So a passkey is bound to a relying party ID, which is a domain string, and that domain string can be a top-level domain, and then any subdomain, the passkey can be exercised at any subdomain of that.
Okay, one more.
How do you create those passkeys? Any backgrounds? Do you use any algorithms or?
Magic. No, so the passkeys are created through that WebAuthn. So I'll hand this to Matt because he can lead you through it better. But basically, there's just two API points: navigator.credentials.create and navigator.credentials.get, and those are the only two functions that you need to do a passkey.
So I guess I want to clarify real quick. Are you talking about like from the website, how it calls the API, or are you talking about like the derivation of the key pair? That's it. Thank you.
I can use the same technology to create new passkeys. So how are you securing those? How is it unique to a user? What type of inputs that you're getting from the user to get it? If you use FIDO tokens, that means you're using biometric, right? But if you're directly going to a website to create passkeys, how would that generate a unique passkey?
Yeah, so the authenticator in both of those scenarios, the authenticator is responsible for generating the credential key pair, and the hows of the authenticator generating that probably documented.
All I'll add is that the relying party sets a list of preferred algorithms, which are the things that it'll accept. And there's two predominant ones in the market today: EC256 and RSA SHA-1, which Microsoft was getting away from, right? So, and there are a couple of others as well. So a relying party says, I'll accept keys that match these algorithms as an ordered list. And then it's up to the authenticator to say, yep, I can honor that list, generate a key pair, here's my public key. It's that simple. So it's not done by the browser, it's not done by the human, it's done by the authenticator.
Is there a place that it gets stored?
It depends on the authenticator's own logic. So in the case of, say, I don't know, a hardware security key, yes, it's stored on the physical key, along with metadata. This is something I said right at the start. Along with metadata such as the user's display name and user handle or user.id, so that it can be used in a prompt to the user for the typingless flow, the passwordless login flow, without the relying party even being aware that at that time the user actually has a passkey. So yes, it's stored logically on the authenticator, and in some cases physically on the authenticator. And I say logically because where the passkey sync providers store it is voodoo magic that they all do their own way.
So we should wrap there, unless it's like vitally.
You can find us in the hallway.
Hey, thank you all for joining us for this masterclass, and help me thank Shane and Nick and Matt for a great session. Thank you.